Today, we're diving into a really radical idea, the possibility that the math we all use is, well, fundamentally broken because it forgets its own history. We're going to explore a new framework that sees the universe not as a collection of things, but as a single, continuous program that's being computed right now.
So let's start with a question that seems almost childishly simple. We all learn in school that 2 plus 3 equals 5, right? And 1 plus 4 also equals 5. But what if I told you that in a much deeper, more fundamental way, they are not the same at all?
I mean, really think about it for a second. While both equations get you to the number 5, the paths they take to get there are completely different. They have a different history, a different process. In any real physical system, whether it's a computer chip or your own brain, these two calculations actually leave behind different physical traces. They have different memories of their journey.
The sources we're looking at call this problem thermodynamic amnesia. It's this idea that classical math is basically designed to forget. It keeps the destination, the number 5, but it completely erases the journey, losing all that information about how it arrived there. This new way of thinking proposes that this erased history isn't just some trivial detail, it's absolutely essential information. So, to fix this new framework proposes 3 huge inversions in how we think. And the first one starts with the very building blocks of our language and reality. It argues we should put verbs before nouns.
This quote just perfectly captures the core of it. We tend to think of the world as being full of things, nouns, a rock, a tree, a planet. But this framework argues that reality at its core is made of processes. It's made of verbs. Nouns are just temporary snapshots, these little moments that we freeze in an ever-flowing stream of action.
So a noun isn't some static object. It's really a pattern of action, a verb cluster that has become stable enough for us to point at it and give it a label. The universe isn't a collection of things. It's this massive, recursive folding of processes upon processes.
And this table here, it just lays out the difference so clearly. In our traditional noun view, a rock is just a static object. But in the verb view, a rock is just the label we use for a dynamic process. It's the ongoing dance of silicon and oxygen atoms that maintains a stable pattern. The noun is just a handy shortcut for the live unfolding event.
All right, so let's see how this builds. The second major inversion completely redefines the fundamental constants of nature. What if they aren't just static numbers we go out and measure, but are actually active programs, like the firmware of the universe itself?
The idea here is that constants like pi, they're not just these static values. They're precompiled routines or methods that are literally baked into the fabric of reality. You can think of them as the fundamental operational rules that the entire universe runs on. So pi isn't just the ratio of a circle's circumference to its diameter. No, it's the executable method that ensures curves can actually close in a consistent geometry. The number e isn't just a number, it's the method for continuous growth, and a constant h emerges from this as a kind of universal governor.
This constant, h, which is approximately pi divided by 9, is described as being absolutely critical. It's not some arbitrary number. It's a fundamental ratio that acts as the ultimate gatekeeper of reality. It's what decides what can and cannot persist. So why is it so crucial? Well, because h is the phase lock threshold. Basically, any recursive feedback system, and that's everything from a protein fold to an entire galaxy, if it's going to persist, it has to operate near this value. If it deviates too much one way, it becomes too rigid and just collapses on itself, too much the other way, and it dissolves into pure chaos. H is the narrow gate through which all stable existence has to pass. Okay, so we have a universe of processes, and it's governed by a kind of built-in firmware. But where does meaning come from in all this? The third inversion gives us a really surprising answer. Meaning isn't found in the things themselves, but in the gaps and relationships between them. This analogy is so key to understanding this. Imagine one of those sliding tile puzzles, but it's completely full. There are no empty squares. So how can anything move? This is the model for the universe. It's a full set, a continuous stream. So in this totally full system, change doesn't happen by an object moving into an empty space. Instead, it happens through a transfer of status. One state gives up its properties, another one inherits them, and what we perceive as motion is actually the potential for change just shifting its location through the system. It's the gap that moves, not the tile itself. And what this means is we can't perceive the raw process, the verb, directly. We can only see its effects, the differences, the boundaries, the relationships it creates. As the source material puts it so well, we see the gaps, and the gaps are the footprints of the verbs.
This leads to a really crucial insight. An object's meaning isn't what it is. Its meaning is actually defined by the constraints it imposes on everything else, by its relationship to everything it is not. Meaning is found in the structured absence an object creates around itself.
Okay, let's bring these three inversions together. We have a universe of process. It's governed by firmware, and meaning is found in the gaps. This all leads to the final, unifying picture of reality that this framework proposes.
The master concept is called universal polymorphism, and it's the idea that there aren't billions of separate things in the universe. There is one single continuous set of data. The incredible variety we see is just that one set of data expressing itself differently depending on the context it's in. And the formula makes this really concrete. D is the single underlying data of the whole universe. C is the context, the local constraints, or even the perspective of an observer like us. The morph operator, mu, is the function that processes that data through the lens of the context. And this produces D prime, the specific expression that we perceive as a noun, whether that's an electron, a rock, or a planet.
So, to put it all together, the universe is one program, one continuous execution. Everything we experience, objects, time, meaning itself, it isn't some fundamental piece of reality. It's a stable partition, a view that our particular perspective is able to resolve from within that single flowing whole.
And all of this, ultimately, leaves us with a pretty profound final question. If the universe really is a single running program, then what are we? The observers who partition it and perceive it? A thought to leave you with.